Hello. Today I'm going to discuss about programmable logic device. Under this, we have discussion about programmable ROM, that is read-only memory. Then we have programmable logic array, and third one is the programmable array logic. So one by one, we'll see what is the basic difference between the block diagram as well as in the design process. The first one is about programmable ROM here. So in this block diagram, you can see that first section we have fixed and array. And second section we have programmable or array. So in this, so here, if you observe first block diagram, we have either we can use the fixed and array or we can use the decoder. So already you have information about the decoder. The decoder can be designed with the n inputs. We have to the power n outputs. Second block diagram is about that is the programmable or array. So now we are going to take on function. So that function is f1, another function is f2. Here we have four variables a, b, c, and here main terms are given for the corresponding function. So this can be designed either with the help of AND array or with the help of decoder. So first, it's easy to design with the help of decoder. So since here we have four inputs. So in case of decoder here, we are going to take n as the 4. So we'll have to the power n outputs. So that is going to be to the power 4. That is the 16. So in the left side here, we are going to give the input. That is the A, B, C, D. And this decoder size is 4 cross 16 decoder that we are going to use here. Now, here we have 16 outputs. So those outputs we can write 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. So in the digital electronics, always we start counting with 0. That's why we have 0 to 15. So after that, if you see here, we are going to use the concept of this array logic. So when we try to give the connection with the help of array logic, so suppose for example, we are using the OR gate. So single inputs is given to the OR gate, and here whatever inputs are there, that will be connected here with the help of cross sign. That cross sign is going to represent that fuse is inset. So now we have only two output functions are there. So we are going to take two OR gates. How many outputs are there? That much OR gate is required. And size of the decoder is decided on the basis of input variables. So since here we have 4 input variables, so output of the decoder is 16. So we have taken 4 cross 16 decoder, and it has output from 0 to 15. So now, since we are going to use logic array, so finally, that symbol we are going to use. So the connection we are going to give to the OR gate here. So one OR gate will give the output. That will be the function F1. Another OR gate is going to give the output. That function will be f2. So now in this, if you see the function f1, it has mean terms 0. We'll make the intact here with 0. Another is 1. So we put the cross here. Again, we have 2. So that is cross here. Again, we have 3. So that is also cross. Next is what? 6. We'll put the 6 cross here. Next is the 9. So we are crossing here. And last one for the function f1 is the 11. Similarly, we can represent for the another function. So that function f2, if you see the mean terms are here, is given 0. So for that 0, we are keeping cross. Again, 1 is also there. Next we have 6. And next we have 8. And next we have. So easily we can connect what are the values are given here, what are the midterms are given. On the basis of that, we are able to make the connection here. So this F1 is going to represent this OR gate output F1, and another OR gate output is what? F2. So easily we can connect in place of connecting so many wires from the decoder output to the OR gates. Better we can use the concept of array logic so that it can be constructed. So here main concept is that first part is the fixed AND array, or we can use the decoder with the appropriate size. The size of the decoder depends upon the how many input variables are there. So in our case, we have taken example for 4 input variables. So the decoder size is 4 cross 16. And second part of this PROM is the programmable. So this OR array is programmable. So that's why we are giving the connection with the help of array logic. So if we can see this one also with the help of AND gate also. So in case of AND gate, if you see that, we can see the different connections, how it can be going to be the value. Now, same thing here we are trying to implement by using the AND array. So here, if you see that for this, we have to go for the scheme. So you can understand about this scheme map. Here we have 4 variables are there. So in the scheme map, we require 16 boxes are required. So in the 16 boxes means we'll have 4 rows and we have 4 columns. So on the basis of this 4 rows and 4 columns, we can give the a space for the mean terms, where these mean terms will be located. So here left side, we are giving the inputs, that inputs we are giving, that is here AB, and this is the CD. And here at a one time, only one variable change. So we have 0, 0, 0, 1, 1, 1, and 1, 0. This side again 0, 0, 0, 1, 1, 1, 1. And here midterms 0, 1, 2, 3, 4, 5, 6, 7. And here we have 8, 9, 10, 11, and 12, 13, 14, 15. Now, whatever mean terms are given, that we can put here for that one. So 0 is given, so 1, again 1 is given, so we are marking here. Again 2 is given, 3 is given. Next we have 6, and again we have 9, again we have 11. So here, if you see that, in this case, in the first column, we have single one. But in the row wise, if you see that, in the first row, we have 4 ones are there. So this we can make the combination of 4 1. That is called as the quad here. So here, row wise, what is the common? A dash, B dash is the common. And here, column wise, will not get anything common. Second combination we are going to make here with the help of here mean terms 1 and 2, and another mean term we are taking 9 and 11. So by using the concept of symmetricity here, so now we'll see first row and fourth. First row and fourth row, what is the common here? B dash is common. And if you look for the column wise, so what is common here? D is the common. This product term is B dash D. Now one more pair we can make here with 2 and 6, since only one mean terms are left. So here if you see the row wise, first and second row, what is common here? A dash. And column wise, what is common here? C and okay. So that's why function f1 is written here, A dash, B dash. And here we have another product and B dash D, and third one we have A dash C D. Similarly, you can go for the K-map of F2. So that also we are going to get B dash C dash plus A dash B C D dash. Now, since it is the first part is what we have fixed and array. So first we are going to give the inputs. So all inputs we are going to represent here. So if you see that this literals having A dash or B dash, some literals are with complement, some are without complement. So to represent that, we are going to use the buffer here. If it is connected to this part, it is without complement, it is connected here, that is the with complement. This is the A. Similarly, we can take the another buffer for the another input. So here we have 4 inputs. So we are going to get 4 buffer here. So this is for the B. Similarly, we have C. For that C also again we have to take another buffer. And we can connect here. So this is again C. Similarly, we'll have for the D also. So how many inputs are there? That much buffer we are going to use here. So on the basis of, you'll see that in the bottom side, this represents D, this represents the D dash. Similarly, for other also, this is the C, this one is the C dash. And similarly, again, here we have B, B dash. And this is the A, this is the. Now we have two functions here. So we'll have two OR gates. So first we are going to give the connection of the AND array. So AND array is not programmable here, it is the fixed one. So first we will see that here all product terms, whatever we have, 5 product terms are there. All product terms are unique here. So we are going to take the 5 AND gates are required here. So here we can't use the array logic symbol since it is not programmable. So for the first AND gate, input is what? A dash. So we are going to connect the A dash to the first AND gate. Again, another is what? B dash. So we are going to connect the B dash, that is the second input, to this AND gate. And finally, this AND gate will have output. So this output is here, A dash. Now we have, we take the another. So this is the second term. We are going to take here B dash B. So B dash. So B dash will be connected here to the second AND gate, and another input is what? D. So D is the non-invertible one. So this section we have to connect here. And again, we are going to draw the output line here. So this one, what we have here, this AND gate is going to give us B dash D. Similarly, we have another gate for that. We are going to take A dash B D dash. So first we'll connect with A dash. So this is connected with A dash. Next we have C. So next we are going to connect with C. And another is what we have, D dash. So that we connect it with D dash. So we can take the wire properly, so it should not that. So we can use the scale also. So D dash. So this output here we have that line we are going to draw. This is your product term with A, C, D dash. We have another product term again. So that product term is we are going to take that is the B dash C dash. Now this will be connected here with B dash, and this another will be connected here with the B dash. So finally, with the 4 product terms, so that we have here B dash C dash. And last product term is left, so that we are going to connect again. So that is the A dash B C. So distinguish this, we can choose the different colors. So now we have first connection is what here. So we are connecting with A dash. Second one is E. So we are taking the second wire. Next we have C. So we are taking the third wire. And last one is what we have, D dash. This output we have, this is what here, A dash, B, C, D dash. Now finally, we are given the connection for the all AND gates. So AND array, fixed AND array, we have given the connection. Now we have programmable OR array. So this all both OR gates we are going to connect here. So one will give the function f1, another is going to give the function f2. So this one we are going to take for the f2, and this one we are going to take for the f1. So in this part, f1, you'll see that it is connected with what are the product terms. There we are going to give the cross connection. The cross connection so that it is fuse is needed, that value is 1. So here for the first function we have A dash, B dash. For the second we have B dash B. For the third one we have A dash C D dash. And here for the F2 we have B dash C dash, and last one is A dash B C D dash. So like this we are able to design the PROM with the help of fixed AND array as well as programmable OR array. But if suppose for the examination point of view, if there are not information that designed with the help of AND array or decoder, then we prefer the decoder so that we can design it in less time and we can save the time also. Now we are going to see about programmable logic array. So in this programmable logic array, so before that we have seen the PROM. So in the PROM we have seen that which was programmable only OR array was the programmable, whereas AND array was the fixed one. But in case of PLA, that is a programmable logic array, in this first section is also programmable as well as second block, both are programmable only. So we should be careful in this. So when we are going to draw here and here, we don't have option to choose decoder. Since all whatever variables we are going to get here, all combinations will not be represented here in case of PLA. So that decoders are not useful here completely. So that's why we are going to use the AND array only. And another thing is that it is the programmable also. Now, if you see that in this, it is written that implement the following Boolean function by using PLA, but condition is given that we have to use only 4 AND gates. So 4 AND gates, we have to choose 4 product terms. These product terms should not be more than 4. So that when we are going to draw the K-map, then with the help of that, we will be able to recognize these values. Okay, so that we are going to see here. So now first we have to look for the K-map. So here, if you see that we have 3 variables. So in case of 3 variables, to the power of 3, we require 8 box K-map. For the both function, we have to go for the K-map. So first we go for the function F1. So we look for the K-map here. So since we have 3 variables in the input, so we'll have 8 boxes in the K-map. So it will have 2 rows and 4 columns. So this side here we have input is A, and this side we have BC. So this literal 0, 1, here we have 0, 0, 0, 1, 1, 1, 1, 0. Since at a one time, only one bit should change. Now for the difference, inside this we can write the mean term. This is the 0, 1, 2, 3. This is the 4, 5, 6, 7. Now what are the values are given? For that mean term, corresponding mean term, we are going to write 1. So for first one, it is given here. This is the 3 is there, 5 is there, 6 is there, 7 is there. So now, before doing this combination and all, we can have representation of the mean terms of the F2 also, since here they're asking that we require only 4 product terms. So we can have clear view, otherwise F1, F2 we have to do separate again. If we are not getting 4 product terms, then we have to look for the complement of one function or complement of both functions to make number of product terms as 4. But generally, If you have complement of one function, then this is going to give us desired result, whatever situation demand is there. So this is 0, 1, this is 0, 0, 0, 1, 1, 1, 1, 0. So someone who having difficulties in the K map, they can observe here also how we are doing. So 0, 1, this mean term is 2, 3, this is the 4, 5, 6, 7. So this one we are writing on the basis of like this cell. Here what we have 1 and here 0, 0. So 1, 0, 0. Bind is what? 4. That's why we are writing here 4 or whatever thing. Now here for the second function, mean terms are given. That is 0, 2, 4, 7. So now if you look in this case, you have 0, 2, 4, 7. So if you see that position of the mean terms are not same. So now if we make the combination here in the first function, so we'll have 3 pair here. In the second function, if you see that one pair is this one, that is the first column, and these two are isolated. So in this case, number of product terms are going to be more. So either we go for we can take the complements of F1 or we can take the complement of F2. So that we can have a proper function in which we'll have only 4 n. Suppose, for example, now here we are going for the complement of the first function. So complement means where mean terms are not available, there we are writing the 0, 0, this is 0, this is also 0. So now we'll write the 0 in the F1. If you see that here, so two mean terms, first column is same, again last one is also same. So we are seeing that we have many combination which is going to be same. That's why we will look for the complement of the first function itself. So now here we'll have one pair of this. So this pair equivalent product terms are here. Row wise nothing is common, so column wise we have B dash, C dash. Another again adjacent is the that we can make the combination. So these two 0 we can make one pair. So this value will have row wise common is A dash and column wise common is the B dash. Another third one is again pair is possible. In that we'll take symmetricity of this and symmetricity of this. So this is going to give us row wise common is again A dash, column wise common is what? C dash. So this function is what? Complement of F1. So we are writing F1 dash. That value is what? A dash, B dash plus B dash, C dash plus A dash, C dash. And we know that complement of the complement is the number itself. So if you'll apply the complement here in the both sides, LHS and RHS, so we'll have F1 complement of complement, so we'll get F1. And the RHS side, we have A dash, B dash plus B dash, C dash plus A dash, C dash, this complement. So now we got the F1 function. Now we'll look for the F2 function. So in the F2 function, if you see that this pair we have, so that row wise column common is nothing, but column wise we have B dash, C dash. Another is symmetric one. So that symmetric, this combination will take this mean term and this mean term. That value is row wise common is A dash, column wise common is C dash. Now this one is left isolated. So this is not coming in any combination. So here row wise common is A, column wise what we have A, B, C. So this function app2 is A dash, C dash plus B dash, C dash plus A, B, C. So now if we'll compare both functions, we'll look for the product terms. So here we have how many unique product terms. So if you see that A dash, C dash is common in both, then we have B dash, C dash common in both. So these two terms are common. So we have one product term is this, second product term is this, third product term A dash, B dash is available only in the function F1, and ABC, fourth product term is available only in the function F2. So finally, our requirement is what here? We should have 4 AND gates. So since we got 4 unique product terms, so our requirement is fulfilled. So now we got the function F1, F2 as per the given condition. So now we can go for the design of this so that we can implement this. So that design part we are going to see with the help of these two functions. So now we are going to implement these two functions. So already we got the proper number of product terms. That requirement was 4. So now first we have input side. So again we have to use here buffer. So we have 3 inputs are there. So we are going to use 3 buffers here. This one is connected here. This is here. So this input is A for us. Then we have another buffer that we are going to use for the B. Again, B is connected here. So one is with complement, another is the without complement. Then we have third one that is for the C. So that we are going to use here. So now all three inputs we have given. So it should be connected properly. So now in the bottom also we can represent so that better visibility will be there. This is C dash. Then we have this one is B dash, and another we have A dash. So A dash. Since we have now 4 product terms and this end array is programmable here, so we can use the logic wire connections. So that is the logic array. So single wire we are going to connect to each end gate. There will mark the whatever product term we have. So corresponding whatever literals are there that we are going to take here. So in the first case, if you see that this one we are going to utilize for A dash, B dash, A dash, B dash. So here we have to put the crossware at A dash, crossware at B dash. Second, we are going to take for the another product term. That product term is A dash, C dash. So again, we have here, this is the A dash, and last one is the C dash. Then we have third product term. That third product term is B dash and C dash. So B dash, we have to mark the cross for the B dash. Then we have here C dash. And fourth product term is ABC. This is the ABC. So A is marked here, B is marked here, then C is marked here. So now we have completed the connection with which connection? End array connection over. Now we'll go for the connection for the programmable or array. So that programmable or array we are going to use here. So this connection we have to mark again, and here we are going to get the output. So now here, since we have two different functions and one function is the complement of the and in the form of complement, so we have to use the XOR gate also that we are going to see. So suppose for example, this one we are going to take for the function f1, this one we are going to take for the function f2. So f1 having terms a dash, b dash, so it crossed here, then it has a dash, c dash, third one is b dash, c dash. Whereas for the f2, we have a dash, c dash, we have b dash, c dash, and third one is what here, a, c. So this function is with complement. So here we have last complement is there. Okay. So that's why we have to use the XOR gate we need to use. So now we got here F1. This F1 is what here? This F1, what we have here? A dash, B dash plus A dash, C dash plus B dash, C dash. Now for this we have to take the complement also. So we are going to use here two XOR gate we are going to use. So for the both functions we are going to use the XOR gate. So this is going to give us F1 and we give the connection like this. This is going to give us F2. So now here we are going to give the input. One input will be 0, another input is here 1. So now we are going to connect first previous whatever output we have here. That is function F1. We are connecting with this one, and this F2 we are connecting to the second XOR gate. Now, apart from this, we are going to connect the function that is XOR gate to XOR gate we are using here. Both XOR gate will be connected here. Now we are going to see which XOR gate should be connected to 0 and which XOR gate should be connected to 1. So in case of XOR, we know that if you have X is the one input and XOR with 0, so that is going to give us output as X. So F2 is our same function. So this should be connected to what? This should be connected to 0. So that X XOR 0 is what? X. Next we have X XOR 1. This is complement going to give us X dash. So this XOR gate which is going to give us output F1 that will be connected to 1. So when function we have with complement, then only we have required the XOR gate. Otherwise, XOR gate is not required. Only up to OR gate we are able to get our desired result. So in case of PLA, that is the programmable logic array. First we have programmable AND array, then we have programmable OR array. So here in this we have programmable AND array here. So this is the programmable AND array part. And here we have programmable OR array. Now here which input is not connected? So since it is AND gate, so other inputs, if it is 3-pin, 4-pin AND gate, so other inputs are 1 to AND gate. Otherwise, if any input is 0 to the AND gate, what will happen? Output will become 0. So as per our function, whatever literals are there, that we are connecting, and remaining inputs are assumed as the 1 here. Whereas in case of programmable OR array, in this part, other inputs to the OR gates, other inputs are 0 here to OR gate. Since in case of OR gates, we know that if a single input is 1, output will be 1. So this concept is used here. If complement is there, then only XOR gate is required. Otherwise, up to OR gate only, we are going to get our desired result. So this was the explanation about how this PLA is going to work. Next, we are going to see about how PAL is going to. So in case of PAL, we have concept is what here? In this, important thing is that always we have to keep in mind that we have first part, that is the programmable AND array, whereas the second part is the fixed array. So here product terms are not shared with another function. So whatever product term we are going to obtain for the particular function, that will be product term for that function. Even if product terms are common, so still we require new AND gates. So for the each function, whatever product terms are there, for that we are going to use the separate AND gate. And sometimes, as per the function, to make it equal number of the AND gates, we can use some false AND gate also. So that will observe here how we have different diagrams here. So in this first, we have to go for the K-map. So since it is the 4 variables, so 4 variables K-map means we have total how many boxes are required? Total 16 boxes to the power 4. To the power 4 is what? 16. So total 16 boxes are required. So for the each and every function, we have to go for the K-map. So here, suppose we are going to for the function F1. So in the F1 also we required how many boxes? Means 4 variables are there. For all we require the 16 boxes for all functions. So here we have 4 rows and you have 4 columns. So here variables are given A, B, C, D. Otherwise, if variables are not given, then we can use the variables as per our choice. Here we have 0, 0, 0, 1, 1, 1, 1, 0. If you want means we can write in terms of C and D also, like 0, 0 is what? C dash, D dash. Similarly, here we have 0, 0, 0, 1, 1, 1, 1, 0. And in time mean terms, we are writing for reference 0, 1, 2, 3, 4, 5, 6, 7, and here we have 8, 9, 10, 11, and 12, 13, 14, and this part is 15. Now we are going to locate the given mean term. So for the function F1, we have 2, we have 12. Okay, whatever the terms are given, that we are going to write. 12 is there, then what we have? 13. So now in this we have to make the combination again. What are the combinations are available? That combination we can make. If you see that here one pair is available. So this pair row wise common is what? A, B. Column wise common is what here? C dash. So we have A, B, C dash, one product. And this mean term 2 is, this is isolated. So here row wise we have A dash, B dash, column wise what we have? C, D dash. So finally this function F1 we have, in this we have 2 product terms. This one we are writing as ABC dash plus A dash, B dash, C, D dash. Similarly, we can go for the another function that we have F2. For F2 again, we have to find the K-map to obtain the Boolean function. So if suppose sometimes maybe product terms are given directly. So if product terms are given, then no need to go for KMAP. Direct we can utilize the given product terms and we can go for the design directly. So here inputs are A, B, and this side we have C, D. So finally, these variables we are going to represent 0, 0, 0, 1, 1, 1, 1, 0, and this side also 0, 0, 0, 1, 1, 1, 1, 0. And for our reference, inside we can represent the mean terms 0, 1, 2, 3, this is 4, 5, 6, 7. And after that, 8, 9, 10, 11, 12, 13, 14, 15. Now, whatever mean terms are given, again, that we are going to locate here. So many mean terms are given. So we have 0, first one, then what we have 2, then we have 3, 4, 5, 6, 7. So next is 8, we have 10, 11, 15. So many mean terms are given. So here we'll see that how many combinations we are going to obtain here. So if you see that here, we can see that all four corners having 1. So that by using the symmetricity concept, for this we'll have row-wise what is the common here, what is the column-wise common, that we are going to write. So row-wise what we have common here, B dash, column-wise common is the B dash. Next we'll see that another combination if you have here. So if you look for the second row, we have all fours. So this all four. So what is the row-wise column here? We have A dash B. So next we have another combination. What is another combination? Can you observe here? That is the third column. So third column, row-wise common is nothing. Column-wise common is what here? B. So finally here, F2 function, what we have? A dash B plus B dash D dash plus C. Similarly, we have to find the F3. So in case of PLA, for the examination point of view, if you see that here, many functions are given. Sometimes maybe 4 functions are also there. So it will take little time to go for the K-map. So this process is little lengthy. So now again, last one, this is function is F3. Inputs are again A, B, C, D here. So we have representations 0, 0, 0, 1, 1, 1, 1, 0. And again, this side 0, 0, 0, 1, 1, 1, 1, 0. And for our reference, we can locate the mean terms 1, 0, 1, 2, 3. This is the 4, 5, 6, 7, 8, 9, 10, 11, and this is 12, 13, 14, and this is the 15. So now next is what? We are going to represent the given mean terms. So here mean terms are given, that is the 1, 2, then we have 8, then we have 12, and last one is what? 13. So here we will see that what are the combinations we are able to do. So if you are going to observe in this, these two are the pair. So row wise, what is the common here? A is the common. Yes, A is common. Column wise, what we have? C dash, D dash. Another combination, if you can observe here, we have these two as the pair. So row wise common is what here? AB. Column wise common is what? C dash. So we have AB C dash. And finally, if you observe, these two are isolated. We can't take any symmetricity or anything. So this is the row wise, you have A dash, B dash, column wise B dash, D. Similarly, for this one, we have row wise C, A dash, B dash, column wise we have C. So finally, we got all three functions. We have F3, that is ABC dash plus AC dash, D dash plus A dash, B dash, C dash D plus last term is A dash, B dash, C D. Now we got all three functions. So now next what we have implement. First one is the programmable and array. Second part is the fixed. So that we are going to see here. So now in this again we have three functions f1, f2, f3. So that value should be here. So this is the f3. So this f3 we have four product terms are there: a, b, c dash plus a, c dash, d dash plus we have a dash, b dash, c dash, d, and fourth term we have a dash, b dash, c, d dash. That already we have seen. Now again you have to use the buffer here. For the four variables are there. So for buffer we are going to use. So first one is for the end. This connection here, this bubble shows the inverted output. So here this is the A. Similarly, so this is going to represent the A. This is going to represent the A dash. So we have another one. So this is a buffer for the B. This is the B. So one is the B, another is the B dash. So similarly, the B, this is the B dash. So we can take all inputs with the help of buffers. So this one again we are here for the C. Again buffer is here. This is the C input here. And finally what we have here? C and C dash. And last one we have last variables is D. So that D is connected here with inverter and that one without inverters. So finally we have in the bottom D and D dash. So now in this, now we have to give the connections. So here, if you see that we have how many? Three functions are there. All three functions will be connected here. So suppose, for example, in this case, suppose due to lack of space, we are considering that for the given PROM, if you are going to use only two functions here, F1 and F2. So in that case, how we are going to implement? So for the given problem, suppose we have only these two functions is given, F1 and F2. So F3, we are not going to utilize here in this case. So finally, how we are going to represent with the help of array diagrams. Okay. So first part is what here? That is the programmable. So end array is programmable here, whereas all array is the fixed one. So since it is the programmable, so for the function f1, if you see that here, two product terms are there, a, b, c dash, and we have a dash, b dash, c d dash. So finally, this connection is going to be here. So this is the array, so directly we can connect here. And here both functions want to make it symmetric. So F2 having three, F1 having only two product terms. So we are connecting the one false AND gate also. So that will look better. So this is a false one. Okay. So finally, we are going to give the choose connection. So first product term is this one we are going to take, that is the A, B, C dash. So A should be connected here, then B should be connected here, and we have C dash is connected. So this is given to target. For the second, we are going to take the product term, that is the A dash, B dash, C, D dash. So first what we have here, A dash, next we have B dash, this is the C, last one is the D dash. This is a false connection, so this one we can give as it is. So this OR gate output is represented by the, that is the value is F1. So we are going to give the function F1 here. Similarly, we can go for the another function. So that is F2. So F2 having three product terms, so we are going to connect here. So three wires we are going to connect here. So finally here again connection. If you see that what are the product terms are there, on the basis of this we are going to give the connection. So first one, this one we are going to take for the first product term here, that is the A dash B. So here this choose will be here A dash, next part we have B. Second, we are going to take for the product term, that is the B dash, B dash. So B dash, and next we have B dash here, and third one we have CD. So that we are going to connect that to the C and D. So it should be connected to C and this connected. So this is the output for F2. Similarly, if you are trying to implement for the given example of the previous one, if you are having F3, then we have 4 AND gates are required for that. And if you use the concept of symmetric, then here again we have to give one more extra false AND gate to the function 1 also, which having already one false gate. So we will have 2 false ones. Then again here function 2 have fourth one false one, and F3 having already 4 product terms. Like that we are able to implement. So finally what we are saying that in this programmable logic device, first we have seen about this PROM. So in case of PROM, we are seeing that first block is about the fixed AND array, or we can have decoder, and second block is what? That is the programmable OR array. When in case of PLA, both are programmable, AND array as well as OR array, both are programmable. Whereas in case of PAL, only AND array is programmable, OR array is not programmable. And here product terms cannot be shared with another function. That's why if repetition of product terms is going to occur, then also we have to use the new AND gates. So like this, we are able to realize the PROM, PLA, and PAL. So later we can summarize again. So we have on the basis of that, whatever function will be given, we can do this. So thank you.